Hello, calculus student. In this video, we're going to talk about some regions that are more complex because they are bounded by more than two curves, and there are a lot of top curve, bottom curve, and you have to separate them in different areas. So this is an example. So how do we do this? You will separate the region into two more regions and find the area by two or more different integrals. So for example, this one has a 2 minus x curve, which is a line, and f of x equal to x squared, and also the x-axis. So it's not this area, it's the area above the x-axis. So basically you can see that it's actually bounded by three curves, the x-axis, the straight line, and then the y equal to x squared. And this is the region that we want to find the area on. So if you look at regions above the x-axis, we're always looking at what is the top and what is the bottom. If you separate it into two, you can see that on the left-hand side, you have the top being 2 minus x, the bottom being x, y equal to 0. And then on the left-hand side, the top is x squared, and then the bottom is the x-axis. So the area actually would become on the left side first from is this actually 1? Let's check. If the point of intersection of the two curves is 1, point of intersection, it seems like it is 1. So we'll solve 2 minus x equal to x squared. Solve it as, not enough space here. Be x squared plus x minus 2 equal to 0. We can factor as x plus 2, x minus 1, because when you multiply it's negative 2, when you add them it's 1x. So x is equal to negative 2, like that means on this side there should be a point of intersection of a negative 2, and on the positive side is x equal to 1. So it is x equal to 1. So our area would be separate, and from 0 to 1, the top graph is the x squared graph minus 0, right, dx. And the bottom graph is 1 to 2. Is it 2? Yeah, the point of intersection is 2. And the top is 2 minus x, but minus y equal to 0, minus 0, so dx. So basically you would do it x cubed over 3, 1, 0, plus 2x minus x squared over 2, 1, 2. So that would be equal to 1/3 plus, let's say 2 times 2 is 4, 4 minus 4 over 2, minus 2, minus 2 minus 1/2, right? So that is 1/3 plus 2 minus, or 2 plus 3 over 2. So it'll be 7 over 2, 1/3 plus 4 plus 7 is 7 over 2. Common denominator, 22 over 6, 21 over 6. 21 plus 2 is 23 over 6. Let's do the checking. Oh, I have a typo here, so 2 minus, so this would be a subtraction. 2 minus 3 over 2 is just 1/2. So 1/3 plus 1/2 is 5 over 6. Sorry, this is actually wrong. Yeah, a lot of sign error, so it's 5 over 6. This should be right. Okay, so then the second one is when the area is treated as you have treated in like in the intervals of y. So and also so y is between c and d. We always use c and d for y, and then the function that you were given is not y equal to, is x equal to, x equal to. So basically, it's like the other way around. So if that is the case, we would not look at which one is the top, which one is the bottom. We will look at which one is the left and which one is the right, left and right. So the area would be from the right side to the left side. So you can look at a representative rectangle as like this, and then dy. The heights or the rectangle would be the one on the most right would be u of y. So you would say A would equal to CD from C to D, but u of y minus a v of y, because u of y is greater than or equal to v of y dy, because this is dy. So everything is in terms of y. Okay, so this is the formula, but no, yeah, if, what do I want to say? If you have y equal to f of x, you have to solve to solve x equal to u of y and etc. So this would only work if u of y is on the left, is greater than a v of y. This is on the left side, this is on the right side. You're looking at left and right graph. So the how-to would be just before you have to look at which one is on the left and right. So so this is an example. So sketch the region 3 minus y square. Now 3 minus y square is using y as the axis, and so this is y square. This is y square. So minus y square would be on this side, and 3 minus means you add 3, so it would be 3, and then this is facing the negative side of y squared. 3 minus y squared. And then x is equal to y plus 1, so it is harder to graph. Let's say y is equal to x minus 1, right? So be here, minus 1, and then, yeah, like this. The area bound by these two curves. So this would be the area that bounds by two curves. We can obviously see a left and a right, but I don't know the region, right? So we have to look at what the y would be. So solve point of intersection. And we're interested in the y coordinate. So 3 minus y squared is equal to y plus 1. So move everything to the other side, 0 equal to y squared plus y plus 1 minus 3 means minus 2. So 0 equal to y plus 2, y minus 1, using the diamond of negative 2 and 1. Multiply, add. Yeah. So y would equal to negative 2, y would equal to 1. So our y value for this is 1 here and negative 2 here. So in all of this two interval, negative 2 to 1, my 3 minus y squared is always on the left side, and my line y plus 1 is always on the right hand side. So my area would be equal to, what is my AB? My AB would be from negative 2 to 1. Then my left curve is 3 minus y squared, and my right is y plus 1. And then I do dy, because the area looking at it is horizontally. So combine like terms, so this would become a negative 2, 1. Negative y squared minus y, so 3 minus 1 is plus 2 dy. Put in the calculator. We can actually try to put in the calculator. It's the same as, okay, so do I have one open? Oh, no, I don't want it to leave this. So, FNINT from, what was it? Negative 2 to 1, negative x squared. Negative 2, negative 2 to 1. Negative x squared, although we do, oh, what is a theta? Okay, I have to change it back to function. Radian. Okay. Exit. Okay, negative 2 to 1. Negative x squared. What was it? Minus y plus 2. Minus x plus 2. Actually, it takes longer than doing it by hand. 4.5, or, okay, if you want to switch it to fraction, 9 over 2. So that's equal to 9 over 2. Let's do it by hand once. So do I have enough space? Just not, I don't have enough space. So it'll be negative y3 over 3 minus y squared over 2 plus 2y. Integral from negative 2 to 1. Negative 2 would be negative, so it'll be 8 over 3 minus 4 over 2 plus, minus 4. Minus 1 will be negative 1/3 minus 1/2 plus 2. Okay, so that would mean 16 minus 12. Oh, so this is a 2, right? This is a 2. So minus 6. 8 over 3 minus 6. Yeah. Minus negative 5 over 6 plus 2 is 12 minus 5, 7 over 6. So this would be 18 minus, so would be negative 10. Negative 10 over 3. So, well, how come I got... Not 4 square, but 4. Minus 2. Minus 4. So it's minus 6. Minus 18 over 3. 8 minus 18 would be negative 10. Oh gosh, I should do one. I switch it. So when I plug in, I think I'm just gonna do 9 over 2. But yeah, I should plug in 1 first and then subtract negative 2. But I try. And then because I don't want the video to be too long. So example 10, so we want to find the area bounded by the same things that we did in example x squared and 2 minus x. This is x equal to 1, right? This is x equal to 1. But instead of writing it, we can see that this is actually the left and this is the right. And then our intersection would be, the intersection is when x is equal to 1 is the point of intersection. We solve it from example 8. What is my y value? But my y value would be 2 minus 1 is equal to 1 also. So my area, I can write it as like horizontally. Think of it as from 0 to 1. The right hand side, 2 minus x. Oh no, so y equal to 2 minus x, y equal to 2 minus x. So x equal to 2 minus y. We have to solve everything as y. So be 2 minus y minus, what about this curve? This curve would be y equal to x squared, x would equal to root x, root y, right? So minus square root of y. So dy, right? So let's see if we can get the same right, same answer over 2 minus, oh, this would be 1/2 plus 1 is 2 over 3, y 3 over 2. Evaluate 1 to 0. So that means just 2, right? 2 minus 1/2 minus 2/3. So that would equal to, let's say 6. 12 minus 6 minus 3 minus 6 minus 4 over 6. So be 5 over 6, the same as what we have in example 8, right? So you can, where's example 8? Yeah, this one. Oh, no. Example 8. Oh, the one with the 2. Yeah, this one. So you can do it with 2 dx kind of integral, or you can do one integral with the left and right formula. But because the interval is from y, you have to find the y corresponding part of y, and also all of the formula need to change into y because you're doing dy. So that is all for this. The third video is about finding area where the interval is with all the x equal to y kind of formula, and you have y interval, or you can have a complex region treated as left to right, and then do dy.